Welcome in Dark Core. We previously reported that in July 2025, astronomers confirmed Comet 3I-ATLAS, the third interstellar object ever discovered. Since then, new findings have revealed it to be far larger and heavier than its predecessors, placing it at the center of scientific debate. In this video, we'll explore what makes 3I-ATLAS an exceptional interstellar comet and why it could reshape our understanding of these rare cosmic visitors. Discovery and first measurements. The first detection of 3I-ATLAS came on July 1, 2025, when the ATLAS telescope in Chile identified an unusually fast-moving object. Follow-up observations quickly showed it was traveling on a hyperbolic trajectory, a path that isn't bound to the Sun. That meant one thing: it came from beyond our solar system. This made it the third interstellar visitor on record, joining ʻOumuamua and Borisov. Each of the three looks and behaves differently, underscoring just how little we know about such bodies. Early size estimates put the nucleus of 3I-AT at about 5.6 kilometers across. That alone would make it larger than Borisov. But what stood out most wasn't its size, but its motion under outgassing forces. Comets are dynamic objects. As sunlight warms their surfaces, frozen gases sublimate, escaping as jets that push against the nucleus like miniature thrusters. This often produces a measurable non-gravitational acceleration. In ʻOumuamua, that acceleration was debated because it was larger than expected for such a small object. In Borisov, the acceleration was consistent with what comets normally show. Astronomers tracked its orbit using data collected by 227 observatories worldwide between May and September 2025. Despite clear evidence of gas and dust activity, the object's path barely shifted at all. The deviation from gravity alone was less than 15 m per day squared, remarkably small given the visible outgassing. This mismatch suggests the comet's nucleus must be extraordinarily heavy. By modeling the balance between the venting gases and their measured acceleration, researchers concluded that their mass is at least 33 billion tons. For comparison, Borisov was smaller by several orders of magnitude, while ʻOumuamua was estimated to weigh only a fraction of this. Though not as large as Bernardinelli Bernstein, it is exceptional for an interstellar comet, raising questions about our assumptions of such visitors. Why astronomers call it an anomaly? Astronomers use the word anomaly not because 3I-ATL is unnatural but because it doesn't fit current predictions. Models suggest that interstellar space should be populated mostly by small fragments left over from the formation of other planetary systems. These should outnumber large bodies by a wide margin. If that's true, then our first discoveries should have been of smaller pieces, not kilometer-scale giants. Instead, all three of the interstellar objects we've detected so far are relatively large. 3I-ATLAS, at over 5 kilometers wide, is by far the heaviest yet. The odds of spotting one this massive so soon while missing countless smaller ones are low, and that is what makes it puzzling. Beyond its size, it shows chemical and optical differences from most solar system comets. Data from the James Webb Space Telescope revealed unusually high amounts of carbon dioxide relative to water, placing it among the most CO2-rich comets studied. Ultraviolet observations confirmed that it is also venting water vapor at large distances from the Sun. Light polarization studies, which examine how sunlight scatters off dust, revealed a distinct pattern not seen in typical comets or asteroids. This hints at differences in dust grain structure, possibly reflecting the conditions of its birth environment. Some early data even suggested nickel without iron, an unusual combination since the two are generally linked in natural processes. Whether this is a measurement artifact or a real signal remains to be confirmed. Together, these features suggest it is not only large but also chemically unusual. This has fueled speculation. Harvard astronomer Avi Lowe suggested that if the mass and composition anomalies hold, natural explanations might fall short. NASA's Tom Statler puts it simply: it looks and acts like a comet. Still, its anomaly forces astronomers to ask, interstellar objects bigger than expected, or other smaller ones just hiding? What to expect next? While debates about its origin continue, 3I-ATLAS is also an unfolding event. Its approach to the Sun will test how such a massive interstellar comet behaves under increasing solar activity. One key event may already have occurred in late September 2025. Space weather forecasts predicted that a coronal mass ejection, CME, from the Sun could collide with the comet. If it did, astronomers may observe disturbances in its tail, similar to what happened with Comet Encke in 2007 when a CME snapped off its ion tail. The effect would likely be temporary, but documenting it would be valuable since no interstellar comet has ever been caught in such an interaction. Looking ahead, the HiRISE camera aboard the Mars Reconnaissance Orbiter is scheduled to attempt high-resolution imaging on October 3, 2025. Unfortunately, the comet will then pass into solar conjunction, hidden behind the Sun from Earth's perspective. It will re-emerge in December, offering new chances to observe its coma and tail as activity peaks. Long-term monitoring will also be crucial. The arrival of the Vera C. Rubin Observatory is expected to transform the field. In its first hours of operation, it catalogued thousands of new asteroids. Over years of continuous sky surveys, it is likely to detect many more interstellar objects. With a larger sample size, astronomers will be able to determine whether it is truly an outlier or part of a hidden population of massive objects. The implications are broad. If such large bodies are common, it could change theories of planet formation and ejection in other star systems, suggesting that massive comets are expelled more efficiently than expected. If they are rare, then our detection of one so soon may point to observational bias or to gaps in our understanding of how interstellar debris spreads across the galaxy. 3IATLAS won't return, making this our only chance to study it and learn how interstellar comets form and behave. Outro. 3I is only our third confirmed interstellar visitor, massive, mysterious, and impossible to ignore. As it nears the Sun, astronomers will be watching closely. And so should we. Stay tuned for more cosmic discoveries. Thanks for watching Dark Core.